On the bench today we have a Hewlett-Packard 8444A tracking generator complete with option 59. It covers a range of 0.5 megahertz to 1500 megahertz, which in its day in 1971 was quite a significant range. This is a classic piece of HP engineering. And today we're going to take the covers off and have a look at it and check it out. So I've already taken the screws off. So let's just take this off. And there it is in all of its HP goodness. This is based on YIG oscillators, and it's got pin diode modulators and bandpass filters and all the sort of things that you would expect to find in a tracking generator. It's got a power supply circuit over here, and this board is a modulator oscillator driver assembly. Everything looks in absolutely perfect condition. There's no fan in these things, so there's no fan to push around all the dust and the dirt. So this looks just as clean now as it may have done in 1971 when it left the factory. I can't see any sign of any rework, any new components, any sign of any damage or deterioration or decay. There's no batteries to leak. It all looks in absolutely perfect original condition. And this is partnered up with either an HP 8554B or an HP 8555B spectrum analyzer. So you didn't buy a spectrum analyzer with the tracking generator included because that would have been too expensive. Instead you bought the spectrum analyzer and then paid a small fortune for this wondrous piece of engineering. And whoever the engineers were that designed this, they made sure that when people like me open this up in the future, they wouldn't just see a bunch of components screwed down to an aluminium sheet. Engineers like me would see a street map of what things were and what they did. In a sense, those engineers who designed this in the late 60s effectively were communicating over decades to an engineer like me looking at this for the first time. Quite remarkable. So when we look at the tracking generator from above, you can see that all the text that's been written on the base plate tells you exactly what things are and pretty much what they do. This hasn't been laid out by an accountant or a lawyer who would have cut every corner to cut costs. This has been laid out by engineers who really care about what will be seen by whom when this thing's opened up. Here we are over 55 years later looking at what engineers did in the late 60s. So if we look down there, there's the power board, and then we can tell from the text on the base plate that we're looking at the modulator oscillator driver assembly. And then over here we've got the 500 megahertz oscillator, and you just go around and you just look at what things are. 500 megahertz amplifier pin diode modulator. They've got the local oscillator here with the output mixer. AT5 I think is the attenuator. There's another attenuator there. It's just a matter of reading what's on the base plate. But everything is beautifully engineered. There's no corners cut here. It's all lots of gold plating, high quality connectors, rigid coax where it's needed. It all looks very minimalist, while at the same time looking like everything has been done properly. If we look on the bottom where no one's really supposed to look, it looks just as good and just as minimalist. It all looks just the same as it probably did when it left the factory. All the wiring is perfectly loomed. Very impressive. Right, we've got everything set up to be ready to apply power, and that's what we're going to do. Switch on power, mains power. And switch on the front panel. Right, so we've got 0 volts applied at the moment. So nothing's going to happen in the middle here, so let's just start winding up a bit. We'll put it wind up to 20%. We'll leave it sitting like that for about 10 or 15 minutes to give the capacitors time to reform. It's been a long time since I've had any voltage applied to them, so the electrolytic film that builds up in electrolytic capacitors won't be there. It'll just be a chemical mush. Right, at the fuses, we've got 5.46 on one end and 4.57 on the other end. So they look fine. The fuses aren't blown, they're looking good. Alright, we'll wind up to 40%. Let's see what happens here. We've got volts on one fuse, 7.6 on the other, so there could be a problem there. Alright, I'm going to wind that down. Now I've got an 18 kilo ohm resistor in series with the power supply, so I'm going to take that out of series and see what happens. So we'll switch the power off here. I'll switch the mains power off the Variac, and let's operate. What have we got here? Alright, we're now reached 100% on the power supply. The power meter is showing 13 watts, which is fine. 4 watts of that will be from the Variac, so there's 9 watts being consumed by the tracking generator, so that's fine. And then if we look at the voltage outputs from the power supply, on one we have got 9.99 volts when the spec says 10 volts, and on the other voltage we have got 20.02 when the spec says 20 volts. So for a piece of equipment that was built in the early 70s, it's still holding its exact spec for power supply. It's pretty good. There's nothing gone fizz, bang, or emitted any magic smoke. Everything looks good, sounds good, everything's in good condition in here. I don't have a spectrum analyzer, so I can't tell if it's actually generating an output, but purely on the applied voltage, the power being used, and a visual inspection, it all looks good.